My name is Eli 𝗦𝗀𝘀𝗀𝗶𝘁. I'm a member of the Radicle Agronomics commercial team, specifically with product support. In a moment, we'll hear from Mike Easter as well. He is our commercial lead on Radicle Agronomics. And we're going to talk to you all today about soil sampling. So you've made it through the whole day, right? And a lot of what you've heard today has been very specific to soil analysis. You heard from Reed and Wendy talking about the Radicle Lab, the amazing technology that we have there, and the repeatability of that and what we're able to achieve. You've heard from Brad and Tony talk about the work that they're doing both in the greenhouse and the chemistry lab and in the field to empower that technology with better data so we know how to use it. And then you just came from the tour where you saw the greenhouse, the chemistry lab, and the Radicle Lab room, where all of that technology is continuing to be improved and developed. So a lot of exciting new things in the world of soil fertility, but we're going to talk about soil collection. Because reality is, and I think you all would agree with me, that soil collection is as important, if not even more important, than soil analysis. In fact, the world's best soil analysis really doesn't help us out a whole lot if we do a poor job of collecting the soil sample. But as we go through this, I hope you understand what we're trying to say is better soil collection doesn't mean it needs to be more difficult. In fact, we think it can be just as easy as what we're doing today, just being a little bit more strategic, being a little bit more intentional about how we're pulling the soil sample. We'll step through some ways that we could do that. But before we decide what makes a good soil sample, we need to start to lay out some goals. So what makes up a good soil sample? What could cause a bad soil sample? We sat down and tried to think of ultimately when we're out collecting soil, what are we trying to achieve? Number one thing is soil collection along with soil analysis. We're trying to learn about the soil. We're trying to learn about the physical and the chemical properties. We're trying to learn about the strengths of that soil and how we can leverage those things to continue to grow a better crop. Things like organic matter. Think about what organic matter is able to do for us from a nutrient supplying and water holding capacity standpoint. Think about fertility of the soil and how we can use that. So we want to leverage those strengths. And at the same time, we want to learn about the weaknesses. Things like compaction, things like nutrient tie-up. What are things that are holding us back from maximum yield potential, and how can we manage it or how can we fix it? How are the management practices that we're doing today from a residue management or a fertility application standpoint, how is that affecting the soil? We want to do a good job of representing the field because we know that soils vary, we know that soils within a field vary, and we know that fields vary from one to the other. We don't want to ignore the variability, we want to try to represent it. If we represent it well, we can be confident that every single acre is getting the treatment that it needs. We want to be consistent. So whether it's sample depth or how we're sampling in like a banded fertility field, right? With sample depth, we want to make sure we're getting a consistent sample every single time. Maybe we're in a reduced till situation where there could be some stratification of lime and nutrients, and if we pull a shallow sample versus a deep sample, that's going to affect the result. That's going to affect the prescription that we write on the back end. We need to make sure that's not only consistent within a sampler, but also sampler to sampler, right? If you got two guys doing it very different ways, that's going to cause a lot of noise, a lot of variation, a lot of headaches when it comes to try to figure out how to use that data. And the last thing is we need to be efficient. So whatever tools, technologies, or strategies we come up with, it can't cost us more time, right? Time is your most valuable asset. We need to make sure this is getting done in a time efficient way. And it's really a balancing of all four of these things. So if we sacrifice one for the other, right, we're going to have a poorer product. We can't sacrifice one for the other. A couple of years ago, when we had prototypes of the technologies you've seen today, we took them out into the world and we showed them to different agronomists. Under NDA, we showed them what we had. We said, here's kind of the path we're going. What do you like about it? What do you dislike about it? Are there ways we can make it better? So we got to meet a lot of different people along that path. One of the guys we met shared a pretty funny story with us about one of his new samplers that he was sending out to the field. So the day before, he brought him in, trained him up on, here's your soil probe, here's your soil bags, here's how we collect the sample, here's how you label the sample, here's how you do that all throughout the field. And then the next day, he sent him off to the field with a full day's worth of work. Should have taken him all day, maybe and some, to get all those fields done. So he takes off to go sample. Around lunchtime, the guy comes pulling back in. So naturally, the agronomist thinks, okay, something's broken. he lost his iPad, the bags blew out of the window, you know, the four-wheeler's broken, something happened. So he goes out and says, all right, why are you here? The guy's like, well, I finished. The guy's like, how could you have gotten all of that done in just a half a day? That should have taken you all day. In fact, I gave you too much work. It should have probably taken you 2 days. The guy's like, well, you know, you got all those different soil zones out there. And, you know, you taught me how to go to the middle of each one of those zones. I pull my soil sample and I go zone to zone to zone across the entire field. Well, I started looking at the map and I realized that if you group 4 of those zones together, they all kind of meet at one intersection point. So instead, I just drove to that intersection point and I walked in a little circle around the four-wheeler and I was able to get 4 samples with 1 stop. And he was pretty proud of that. The guy's like, well, that's pretty brilliant. In fact, it's so brilliant, why don't you go ahead and throw all those samples away and go do it again the right way. Now, that guy was sacrificing field representation for efficiency. Albeit, you know, out of ignorance, he wasn't trying to do a bad job. It's just kind of how it happened. But it does matter where we pull that soil sample from. It matters the spot in the field that we stop to collect the sample. We shouldn't just leave it up to chance. Leaving it up to chance would almost be kind of like, you know, if you're going on vacation and don't know where to go, you know, let's just put up a map of the world and we're going to throw a dart at that map and that's where we're going to go on vacation, which is apparently something people do. I don't know, not my thing, but to each their own, I guess. So if we're going to throw a dart at this map and wherever it goes, that's where we're going on our trip, sounds great when you first think about it, until you remember, isn't the Earth like 70% water? Those oceans are pretty big. So if I were to reach back, throw a dart at this map, more chances than not, I'm going swimming on vacation. It seems silly to ignore the information that we have. We know where the land is, we know where the oceans are, right? Just because my dart landed there doesn't mean I have to say, well, I guess we're going to the Atlantic Ocean on vacation. Right? Why ignore the variability and the things that we know to be true? Same thing kind of applies to this field. So these are the fields surrounding precision planting. And you can see they're pretty variable. There's some light spots, there's some dark spots. As you're driving up today, and if you're out of state, you're probably thinking, man, these guys got it good. Flat, black fields, square fields. These guys wouldn't know variability if it hit them over the head. Now, I won't argue that we don't have good soil. We are very blessed with good soil. But I will argue that we don't have variability. I will argue against that. Because we can see on a simple Google Earth image, right? If you pulled out your phones right now, looked up our location, and pulled up the satellite image, this is what you would see. On a simple Google Earth image, we can see there's light areas, there's dark areas, right? As you're driving by, you can see there's some higher areas, some lower areas, some ebbs and flows through those fields. So we can see that plain as day. It would seem a little bit silly to say, you know what, let's just throw a dart, and that's where we're going to collect our soil sample. It's even silly to say, let's throw 10 darts at this field, and that's where we're going to collect our soil sample. We shouldn't leave it up to chance. So when it comes to deciding how and where to pull the soil sample, there's really 2 main ways. You're either a grid system or you're a zone system. And there's different definitions of each. When I think of a grid system, I think of a square pattern on a field with a center point, and I'm going to drive to the center point, collect my soil sample, and I'm going to drive to the next point. When I think of a zone system, I think of unique polygons, unique shapes within that field that are all based off of soil type, topography, yield, whatever that may be, but they're built off of soil characteristics. And instead of stopping at one point in the zone to pull a sample, I'm going to drive through it, I'm going to collect multiple cores and put all those together for one composite sample. So I'm going to step through a couple of pros and cons with each one of these approaches, talk through what we like about each one, and maybe what we don't like about each one. Starting with grids is, they're really easy. Without much time, without much work, without much effort, without much training, I can put a grid on a field, kind of get it where I want it, and sample it that same day. It looks something similar to this. So this is done on the Radicle app. We're going to draw a boundary around the field, and then I'm going to put a grid on that field. I'm going to move it around a little bit, up, down, left, right, change the grid size some, merge some of those grids together, kind of get it lined up with where I want it in the field, pretty much just based off of how the field edges run. But in under a minute, I have a sampling map for that field, and I can go sample it that same day. That's something I can do from the roadside when I get there. So from an agronomist perspective, from a consultant's perspective, that's really powerful. If you've got customers calling in fields as they're harvesting them, that same day, they call that in. You could drive there, create a sampling map, and sample it. For a farmer, that's also pretty powerful, right? I just picked up new ground. I don't have any kind of history on this ground. I don't have yield. I don't have time to pull a soil map. I don't know any background information of it. If I just want a base fertility map of a field, I can create a map pretty quickly, pretty easily, and sample it that same day. Where we start to see the grids kind of start to fall apart is when we start to bring in other layers of data behind them. So these are the grids we just created in the step ago. I'm going to put a soil type map on that, and we can see the grids really don't correlate with the zones, the soil type zones within this field at all. There's a couple big issues we see with this. Number one is a lot of those points fall on the transition lines between two different soil types. So you're not necessarily in one soil type or out of another. You're kind of in a no man's land, probably on a side hill or something like that, in an area that really doesn't represent much of that field at all. It really only represents that one spot in the field. Another issue with the grids is we miss zones completely. So we see that light green 𝗲𝗀𝘀𝗀𝗶 soil type on the left side of the screen. We have points around it, but we never actually pull a soil sample out of that zone. Again, that could be a lighter area, it could be a darker area. We can see it, we know it exists, but we don't sample it. And we're not just going to obviously apply fertilizer at that one point. We're going to apply fertilizer on the entire field. So in order to do that, we need to fill out the rest of the field. Two main ways to do that. Number one is I can either take the data from that one point that I collect the soil sample, and I can apply that to the entire grid. Call that like a grid system, right? So at this point, I'm just using soil type as an example. We look at the soil type underneath each one of those sampling points, and we apply that soil type to the entire grid, and we try to make a map out of that. This is what that map looks like. It doesn't have the natural movements and variability that exist within that field. It looks very robotic, looks very pixelated, right? It also misses zones completely, so again, not very representative of that field, the true variability within that field. Another way to do it, maybe a little better, depending on your school of thought, but another way to do it would be, instead of just applying that to the entire grid, we're going to try to blend those areas together. So we're going to try to average between it and guess what's going on in between those points, commonly referred to as interpolation or kriging. So if we interpolate on the map, now this is what we're left with. Starting to look a little bit more like the soil type map, but there's some clear differences as well, right? If we pull a point here and pull a point here, we just have to guess what's going on in between them. And again, we miss zones, we miss variability. Again, I'm just using soil type as an example, but same thing applies when we're looking at nutrient maps as well. So for example, we referenced this 𝗲𝗀𝘀𝗀𝗶 zone a second ago. We missed that zone completely. What if the 2 points on either side of that zone are both lower testing areas within the field? So all we can know is this is low, this all must be low, right? Because we have no other measurement to go off of. But what if in reality that's a more productive, higher fertility spot in the field? So now we're applying fertilizer in an area where we actually may not even need it, simply because we have to guess what's going on between those points. There's another map, same process, same school of thought. We look at the soil type map compared to the sample points, same issues that we saw before. A lot of those fall on transition lines. Some of those zones are missed or not represented well at all. But that's just one layer of data. This is actually one of my own family farms, so we're able to pull the yield data from this and take a look what that looks like. And we can see there are some lower yielding spots within this field that we miss completely. The most obvious one there is the spot at the north end of the field. Very low yielding. It shows up year after year after year. On a grid-based system, if that was our grid type, we would never pull a soil sample out of that area. Now, is that to say that the problem is fertility related? Maybe not. Maybe it's compaction, maybe it's topography, maybe it's water, either too much or not enough. So we don't know what the issue is, but at the same time, we have no measurement from it. At the very least, we should probably treat that area different because the crop is reacting differently in that area. There are some other zones in here that you see that we miss. It's not just low yielding areas either. Right in the middle of this field is the best yielding spot within this entire farm. However, we're only pulling samples kind of on the outside of it, maybe in lower soil testing areas. So now if we're saying all of these areas are low, we're going to apply a lot of fertilizer right there in the middle of the field when it may not actually need it. So again, the inverse is true whether it's high yielding or lower yielding. So grids are really easy to create. Saves you a lot of time, saves you a lot of effort, maybe saves you a lot of resources. However, they do ignore soil characteristics that we know to be true and we know that they're there and that we know affect fertility and crop health and development. So really the whole goal with zones is to try to group like areas of the field together. Similar in soil type, similar in topography, similar in yield, similar in just their physical and chemical characteristics. So that process looks something like this. We may take a boundary, right, of that second field we just looked at. The next thing that we're going to do is we're going to bring in a soil type map. That's always a good place to start, right? If we're trying to group soils by like characteristics, it makes sense to start with soil type. However, we don't want to just sample on soil type alone. Some of those soil type areas are 15, 20 acres large. We want to cut these maybe into 3, 4, 5 acre slices so that we can get a better representation of that area. So in order to figure out where to cut next, we bring in something like yield. So we can see even within a soil type, there's yield variability. So we cut that and make that its own management zone. To be honest, soil type maps aren't perfect. A lot of areas, people say the Sorgo maps are pretty poor. So we don't want to just rely on soil type. We want to look at yield and satellite imagery. Maybe the soil type lines change a little bit based off the satellite imagery, and we can tweak those by starting to layer those pieces of data together. NDVI, thermal, crop health imagery. Maybe there's things showing up in crop stress that don't necessarily appear on the yield map. But again, there's something is happening out there, and we can go out, we can sample it and figure out what's going on. Another big one that I don't have up here right now is topography, elevation. So we want to group, the hilltops, the side hills, the valleys all together because those are different. Could be different soil properties, could be different moisture values, things like that. We want to group all those together. So the hope is as we group all these pieces of data together, we can kind of look through them all at once and start to see zones start to appear. Zones that appear in yield, zones that appear in soil, zones that appear in satellite and topography, and we start to cut those areas out, again, with the goal of trying to create uniform zones within the field that we can all manage differently. One reason why it's important to layer pieces of data together, so again, this is yield, this is soil type. That low yielding zone in the top of the field really doesn't follow a soil type line at all. It kind of crosses over between two different soil types. So if we were to simply cut this map up by soil type alone, we still may not represent this low yielding spot very well. But because that's a spot that shows up year after year after year, we're going to kind of ignore the soil lines in that area and say, you know what, that's a different management zone. And in the bottom of the field, if that area starts to show up year after year after year, although it kind of appears over multiple soil lines, we can do the same thing. So the great thing about zones is basically, the inverse of the grid system. It groups like soils together, which is what we're trying to do, using lots of data, using soil characteristics, but it takes a lot of time to do that. It takes a lot of training to do that, a lot of know-how to do that. It takes time to bring all of that data together. We hear from consultants say, I can't even get a yield map from a customer, right? So it takes time and effort in order to do that. But is it worth it? So in order to know, we need to measure. So this is a study we did a few years ago. We took one 50-acre field and we sampled it a lot. We sampled it on 1/16th acre grids. It ends up being a soil sample about every 50 feet within the field. This 50-acre field took about 800 soil samples to get that done. And in order to do that, it's a lot of work. You need one of two things. You either need a lot of interns or you need an automated probe. And I'm pretty sure we use both. So the folks at Rogo helped us out with this. They brought their sampling system in to help us get this job done because it was a lot of work, it was a lot of sampling. But we're using this as our truth layer. So now instead of trying to guess what's going on between two different points or guess what's actually happening within a zone we've created, we have an actual measurement from that spot so we can see, is our interpolation actually match truth? And we can test that against different types of soil sampling. So we tested a zone system, we tested a 2.5 acre grid, which is probably the most standard, and we tested a lower density grid system as well. So you can see between the zones and the 2.5 acre grid, it's the same exact number of samples. So this is where we say in the field, right, we can get more strategic about how we're pulling soil samples, but it doesn't necessarily need to be harder. Now, some work went into creating that map, so we don't want to ignore that. Like we talked about, it takes time to make that map, but when we're out in the field actually collecting soil, we don't need to just collect a lot more samples. It could just be that we need to be a little bit more intentional about where we're pulling them. So I want to look at just one layer. So we're going to look at potassium. On the 1/16th acre grid, we can see there's a lot going on. There's high spots, there's low spots, there's everything in between. There's a lot of variability. If we compare that to the 4-acre grid map, it doesn't even look like the same field. We completely missed that low testing area right in the middle. We missed that low testing area in the top left corner. In fact, only 65% of that field is represented accurately based off that 4-acre grid system. And to be completely honest, we're being pretty lenient with what we're calling accurate. You can see in the fine print at the top, if it's within 40 part per million on potassium, we're going to say, you know what, that's close enough. So all that to say, only 65% of the field on a 4.5-acre grid is within 40 part per million on potassium compared to truth. Not good. Here's a 2.5-acre grid along with the smart zones. Now we can kind of start to see some of those zones come to life, the lower area in the middle, some of those other lower testing and higher testing areas around it. If you squint, you can kind of see the same map start to appear. Did it lead to more accuracy? A little. 2.5-acre grid showing 68% accurate, and then the smart zone showing a little bit better at 75%. Again, I would say we're not really satisfied with any of those. The smart zones are showing slightly better representation of that field, but this is why we're saying we don't know if we truly know how to soil test today. There's a lot of different ways to do it, so we're going to start putting that to research, doing studies, try to figure out what is the best way to sample. Is it more samples? Is it more strategic sampling? How many cores should we be pulling? Things like that. These are things we're going to start looking into along with the things that we've already done, and we'll share those as we go and figure out what we find. However, this is just representation only. So we're only talking about how well we're representing the field. At the end of the day, we still need to look at that soil test number and make a decision based off of it. So that's where the work that Brad and Tony are doing comes into play. So the in-field trials, the greenhouse trials, the work that's going on in the chemistry lab, now we can take a soil-specific soil sample that we strategically pulled based off of soil type, topography, things like that, and know exactly how to treat that area in the field. Right? If we're doing all this work to get soil-specific critical soil test values, soil-specific buffer capacities, it only makes sense that we're sampling based off of soil-specific properties. And what we may start to see is there are different types of spread maps for different nutrients. Right? Your map that's built off of organic matter and topography may be great for planting population, but your map for phosphorus may look different than that map. Your map for potassium may look different than that, because we know that the potassium stuff is highly predicated on your clay minerals and things like that. So we want to account for it. So we may start seeing different spread maps for different nutrients. But again, it all comes back to we need to be more strategic about how we're sampling it, because now we're starting to compile data that allows us to know how to treat that. When we bring together better sampling along with data that backs up how to treat it, that's a pretty powerful thing. Now, I want to give you something that we can apply right away. Right? I'm doing a grid system, or I'm not doing anything today. Where do I start? I realize what you're seeing. I don't know if I'm ready to go fully in on the zone thing yet. That seems like a lot of work. This is what I'm doing, or this is what I'm thinking about doing. How could I make it just a little bit better? Well, what if we just bring in one layer of data? Something like soil type. So like I said, our biggest issues with this system is that some of those samples fall on transition lines, some of those samples miss zones completely. So what if we took that same number of samples that we had from earlier and we just move them around a little bit? So now we're off those transition lines. We're in the middle of the zone. If we do have to Krieg between samples, now that's kind of happening on those natural soil lines. So maybe that makes a little bit more sense. And then, if we really wanted to, we can maybe add a few more samples to it, 3 in particular. So now we feel like we have every zone within this field covered, and they are spaced out based on soil characteristics. So now we're starting to take some of those things into account. Now, if you've done this job before, like I have for several years, some red flags are starting to go off in your head. It's like, yeah, but it's really nice to sample on that nice straight grid pattern. It's just down and back on the field. I know exactly what sample I have coming up next. I know exactly what bag I need to fill next. That's easy to train. That's easy to understand. That's easy to implement. So now basically what you've done is you've taken all my sample points, thrown them on a table like a deck of cards, and just mixed them all up. That's really hard to keep track of now. That's going to lead to mistakes in the field, whatever that may be. Or you even added more samples to it. Now I need to track those from field to lab, and then when the results come back, I need to remember, okay, where did I pull that sample from? it can be more difficult. It would be really nice if we had some kind of device that packaged and labeled samples for us so that all we had to do was collect soil. Do you know anything like that, Mike?
You know, at the end of the day, what we really want is a lab result so we can make recommendations, right? This is just an example of a lab result coming out of the Radicle system, but that's really what we want. We want to be able to make a recommendation so that I know what to apply, and based on my equipment, how I'm going to apply it. But to get there, I mean, Eli just complicated our life by saying, hey, you know what, maybe there's a way we can do a better job with a little more work. How many of you need more work? Nobody's putting up their hand. Nobody wants more work. So we have been able to actually fix that. So at worst case, there's no time penalty, even though you're doing more work, or at best case, we can actually increase your soil collection in the field by as much as 30%, depending on the process you're currently using. I imagine everybody in here is familiar with one of these. So this is a paper bag that you send to the soil lab. I can't manipulate this paper bag and run it through the lab. In fact, the soil labs today can't manipulate this paper bag either. The first thing they do is they cut it open, they dump it in the soil boat. All right? So in order to make that process simpler, we need to get rid of this paper bag. So our solution to that is the GeoTube, what you see on the screen there. Now I'm going to pass these around. But almost inevitably, when I pass out one of these with a cap on it, the very first person is trying to pull a cap off. So, and they don't come off very easy. So I'll take that cap off for you. If you just want to pass that down on your side of the room so everybody can take a look at it. So what we've done with this is literally a piece of plastic, right? It has a cap, and on the bottom there's a plunger. Underneath the sticker on that plunger is this little chip. It's a little RFID chip. That records all of the field level data. So where did I collect it from? GPS location, so the coordinates. Who did it? What piece of equipment? Date, time, all that type of stuff is automatically recorded on that. So we now have a device that can containerize the soil so the lab can manipulate that. And we're recording all of the data that we would normally either write on a bag, or maybe we've got a semi-automated solution where we have got QR codes from the lab, we associate that, stick those on the bag instead of writing on it. And the nice thing about that, can you read that? One. There is a word in front of that one, but you kind of need to bring out your hieroglyphics decipherer and figure out what it says. So can you read that one? Sandbox. It says sandbox, right? So yesterday we actually did a relay race outside. Now we're a little wet out there, so we can't do it today. And these are some of the results we got back from our hand labelers. And then we had a really clever guy, because this was a race, right? And he was pretty aggressive. So sandbox became SB, right? Now, at the end of the day, somebody also has to do a lab submittal sheet, put these in a box, and send them off to the lab. But we're able to eliminate all of that record keeping that's done today and containerize that literally in that container. And as it goes through the lab, as the lab manipulates that, one of the very first things that happens is the lab reads that data and now knows where that came from. We're going to come back to the GeoPress in just a few minutes. But let's go back to Eli's map here. So Eli made things a little more complicated here. He actually added a few more collection points. So this would typically make somebody's job harder. With the GeoPress and the GeoTubes, the app will actually walk you through that entire field. And no matter what direction of travel, so if I had to turn north here instead of west, it would show me my next collection point in that direction of travel. So it'll walk us all the way through it, so minimize all of that extra work. Worst case, we want to be on par with how fast you're sampling today. That's the worst case. Best case, if you're running a fully manual system where you're writing on the bags in the field, we can speed you up by even as much as 30% when you calculate shipping times, lab submittal, handwriting, all of that stuff is contributed in that, and we eliminate all of it. Now, how many of you farm? And most of you actually farm. How many of you do your own samples? How many of you get somebody else to pull your cores for you? Okay? So, your sampler is driving through your field and they notice an anomaly. Do you want to know what's happening there? You know, as a farmer, I would want to know what's happening there. If I've got an experienced agronomist who's out doing this and he sees something, chances are they're probably going to go over and pull a sample there and might come back to you and say, hey, I told you I was going to pull 24, but I actually needed to pull 25, and here's why. So your cost is going to go up just a little bit. Yeah, very easy to justify because I see a problem. Let's see if we can figure out what's going on. Now, if it's an intern going to the field that doesn't have very much experience, for example, they might just keep on trucking, go to the next sample location. Doing ad hoc sampling today, especially if you have a system, is not easy to achieve. So I've pre-labeled all my bags, I've already got my lab submittal sheet all filled out, and I want to add to that. It's not easy. So with Radicle on my GeoPress there, I see a problem, I drive over to it, pull a sample, it drops a new pin there. I can add a note to it if I want. Okay, why there's a problem here, we need to figure out what's going on. And then it will automatically label that. So ad hoc becomes super simple. No extra work required except for the couple of minutes it takes to pull that extra sample. This is a field I did in North Carolina a little bit earlier this year. Now you can see that I'm not very good at getting to my target location. You know, some of those are a little far from that center point. But one of the things that we do, you know, if you've got 24 bags for a field and you finish the field and you've got 2 bags left over, it's pretty obvious, right? Well, we have no labeling on these GeoTubes. One thing you can do, though, is pull out the app on your phone and tap it to that RFID and it'll read it and give you all the information right on the app. Okay? But we have some other tools there. I want to finish the field. I've collected 24 of 24. 0 remaining. I did another field in Missouri. It was 42, and I only collected 39 samples. Okay, so it told me I was missing 3, and it actually showed me which ones I was missing. So in this case, when we pull a sample in that location, it turns that area blue and drops that blue triangle. My map was 39 blue squares and 3 white ones because I hadn't collected the sample from there. So just some quick tools to make it a little bit more intuitive in the field. So even though Eli is saying, you know what, if we're more intentional, it actually requires more work, we're not going to slow you down in the field. In fact, we could very much significantly improve performance in the field. All completely automatic.